let's see that same relationship of 2/3 being the same as 8/12, but let's try it using the pattern blocks. I'm sorry, I should change that color. Let's write that, right? 2/3 is the same as 8/12. And if we look at the pattern block, so let's pull out one. What we want to start to pay attention to is, right, this relationship between the size of the pieces. This is an example of the area model without a predefined whole, which means we have to define the whole. And so if we're just focusing on our first fraction, 2/3, we can use this as a whole because we can see each or three of the rhombuses, together, all three of these make up a whole. But now if we're looking about, well, we want to show that it's the same as 8/12. Well, we can't cut up into 12ths, right? The smallest one we have here would be the triangle, and then that would only be 6 in there. So let's define the whole so that way we can create 12ths. And if we know 6 triangles are in the one hexagon, then 12 triangles are in 2 hexagons. So this is, again, those partitioning and iterating activities. So this 2 hexagons is our whole, which means this one triangle is 1/12. And now you can think about this in 2 different ways, this rhombus. We can think about it as 1, 2, 3, 4, right? How many fit in? And then so 4, 5, 6, right? We're going to see 6 as 1/6, or you can think about it as how many triangles, right? How many 12ths make this up, which is, again, is the same as 2/12. And we know this equivalent relationship, but now we can start to see it in the shapes. And so now we're thinking about 2/3, and maybe you want to think about 2/3 like this, right? 2/3 of this hexagon and 2/3 of that hexagon. That's allowed, right? This is now 2/3 of the whole. And so, and that's the beauty of the area model. And then the pattern blocks specifically is that you don't have to do, you can choose to just take up the amount of space. This also shows 2/3 of the whole. And maybe you can't, that doesn't look like 2/3 to you, and that's okay, because we're just talking about the amount of space that the blue ones are taking up over the entire yellow ones. So maybe you want to see it like that. Well, now we're thinking about, okay, so how does these, I'm going to try and highlight all of these and copy them. These 4 shapes, right? So this is showing me 2/3 of this whole, right? These 2 hexagons. And now how do I show that that is the same as 8/12? Maybe we'll put this in blue so we can see this is my 2/3. Well, take the green ones, right? 1, 2, we'll flip it over, 3, and I'll duplicate that now, 4, 5, 6, 7, pull another one down, 8. And now we can see we literally have 8 triangles. Each triangle is 1/12. So we know that this is the same as 8/12, 8 triangles. And just like before, we see that we're taking each 1/3 piece, right? And even though in this case, 1/3 is made up of 2 different pieces, that's allowed, right? Each blue is 1/3. The 2 blues together are 1/3, right? Each single blue is 1/12, right? So this is 1/3, and we see that we're taking it and breaking it up into those 4, oops, I'm trying to grab this one below it, those 4 equal size pieces. And so again, same idea that we saw with the set model, the area model, that was the circle, right? The fraction circles, and then the length model, like the fraction bars. And we can see the same thing with the Cuisenaire rods. I'm going to let you try that on your own and practice this explanation of how we're cutting up each piece, right? So that way we can show these equivalent fractions and show this multiplication of this of 1, right? The multiplicative identity to change, right? The number of pieces and the size of the pieces.